this video, we will be discussing an important term in retrosynthetic or organic synthesis, which is the latent polarity. So what does it mean by latent polarity? So the concept of latent polarity is an imaginary pattern of alternating plus and minus charges used to give an idea about the nature of syntons that result from a disconnection of a target molecule. So the polarities are arranged in such a way that the positive charge is initially placed on the carbon adjacent to the more electronegative oxygen atom. So in latent polarity, you can see there are two patterns of polarity that can exist in a molecule. Okay, when we talk about latent polarity, we need to think about some of the reaction that we have looked at for carbonyl compounds. So the first kind of reaction of carbonyl compound is a nucleophilic addition. Okay, what you can see is that when we have a nucleophile, it will attack the carbon of the carbonyl, and then the electron will migrate from the double bond to the oxygen, and it will result an alcohol. Okay, so if we look at the polarity of the compound, carbon here is plus, partially plus positive, while the oxygen is partially negative because we know that oxygen is an electronegative atom. Another type of reaction that occur in carbonyl compound is when we have a base. So what do this base? What is the function of this base? It is going to abstract the proton from the carbonyl compound, the alpha proton from the carbonyl compound, and then the bond will migrate. Then the electron of the double bond, C double bond O, will migrate to the oxygen. So what happened is that this oxygen, this negative electron, this electron will migrate to this bond, and then the double bond that form here will also, the electron from the double bond here will also migrate and result in this type of compound. Yeah. Okay, so in this case, you see that here the partially minus is on the oxygen, and the carbon adjacent to the oxygen is now partially positive. Okay, and then another types of reaction that can occur in carbonyl compounds is when you have a nucleophile. So this nucleophile will attack the carbon of the double bond, and then the electron will migrate to this bond, and then the electron of the C double bond O also will migrate to the oxygen. And then after that, the rearrangement occurs, so the electron from the oxygen will migrate to the CO bond, and then the electron will move, so it will give you this type of compound where you have also E and also nucleophile. So in this case, this is how we write the polarity, latent polarity. So oxygen always partially minus, and then we have partially plus here, and then the next carbon is partially minus, and the next carbon is partially plus, which is written alternatively. Yeah. Okay, so this is an example of how you can draw the imaginary charges in a molecule. So we need to start with oxygen, because oxygen is the most electronegative atom here. So oxygen is partially minus, and then followed by this carbon is partially plus, and then minus, plus, minus, plus, and this side also minus, plus. And now we have patterns of polarity. Okay, like I have mentioned in the previous slides, so there are two types of polarity, and the first one is the consonant pattern, and the second one is dissonant pattern. Okay, in consonant pattern, normally it involves system that has a 1,3 or 1,5 dioxygen function. And while dissonant pattern involves system that contain a 1,2 or 1,4 dioxygen function. Okay, let's take a look at the consonant pattern. So consonant pattern, in this type of pattern, so a target molecule on this connection can give synton of normal polarities, and the forward synthesis can be done smoothly with normal synthetic equivalents. Okay, and normally consonant pattern occur in system that has 1,3 disubstituted molecule, like this compound. Okay, you see, when we start from C double bond O, normally we will start with a molecule with the oxygen atom, yeah. Okay, in this case, we start with oxygen, so the first one is minus, and then plus, and then minus, and then plus. Okay, let's say we start from COH. Okay, minus, plus, minus, plus. Okay, if we look at the molecule, if you look at this C double bond O, it is plus, and COH is plus, meaning they are of the same polarity. Okay, let's look at when it starts from COH. So it's still plus and plus. So in this type of compound, it can give you normal synton with normal synthetic equivalent. Okay, this is an example of a consonant pattern. So if we have this aldol molecule, okay, we are going to have a C double bond here, C double bond O here. It is plus, then minus, and then plus. So we can disconnect the molecule at this part. Okay, we disconnect at this carbon. So what we get is these two syntons. So these two syntons, if you have um, these syntons, it has normal synthetic equivalent, which is when you have minus, just add hydrogen, so it will give you an acetone. And then, if you have another synton here, it is plus, so you know that when carbon next to OH is plus, it normally will give you an aldehyde, like this. Okay, so how are we going to do this reaction? Is that because you already know this is the synthetic equivalent, so you know that ketone reaction of ketone and aldehyde usually is what we call as aldol condensation. So the forward synthesis of this reaction is when you have acidic proton here, you have a base. So base will abstract this proton, and then it will give you a negative molecule like this. So this oxygen will attack the carbon, the double carbon with the O, carbonyl carbon, and then will result to this intermediate. And then when you have acid, so this minus charge will abstract the proton, and then it will give you target molecule. Okay. And now another example is when we have this type of compound, you see, it also has the same charges. This is 1,4 substitution, 1,5 substitution, meaning 1, 2, 3, 4, 5. So what happened is that this is plus, minus, plus, minus, plus. You see, it has the same plus charge, so it is still under consonant pattern. So when we disconnect the molecule, and then we disconnect at this part, so we get these two syntons, and this one The synthetic equivalent is R and CH3 plus this one, yeah. Okay, so it's the same thing. You do an aldol condensation reaction for this type of 1.15 molecule. Okay, there are also more example. If you see, this is for 1,3 disubstituted compound. Okay, let's say you have this target molecule. Okay, when we want to disconnect, we disconnect at this part. You see, this is plus, and number 3 is also plus. So we can use normal syntons. So when we disconnect, we get these two syntons. And then these two syntons now become a normal synthetic equivalent. Okay, for 1,5 compounds, for 1,5 disubstituted compound, you can also observe it is plus and plus at the carbon 1 and 5. Okay, so it will give, when you disconnect at this part, it will give you two normal syntons and two normal synthetic equivalent. So that's the end of this video. We will continue on the dissonant pattern in the next video.